Hello everyone! Let's solve some exercises about isotopes to test ourselves. Let's start with a direct question about the definition of isotopes. Isotopes are atoms of the same element with different number of electrons, protons, or neutrons. Go back to your notes to check the definition of isotopes. So isotopes are atoms of the same element, which means that they have the same atomic number. So they will have exactly the same number of protons and electrons. However, since they have different mass number, then they will have a different number of neutrons. Let's examine this figure. These are two isotopes of oxygen. Let's find the atomic number of isotope A and B. So first we have to find which part represents the protons and which one represents the neutrons. So we can find the atomic number. So what's the atomic number? Yes, it's the number of protons inside the nucleus. So in atom A, we have 8 red particles and 8 green particles, whereas in atom B, we have 8 red particles and 10 green particles. Keep in mind that these are two isotopes of oxygen, so they are isotopes of the same element. In other words, they will have the same atomic number, which is the number of protons. So in this case, the red represents the protons, because there's equal number of protons in both isotopes. So the atomic number of isotope A and B is 8. Now if we compare these two isotopes, we would find that isotope B has 2 more electrons, 2 less electrons, or 2 more neutrons. Examine these two figures carefully to find the answer. Actually, the isotopes have exactly the same number of electrons, and by examining this figure, we will reach this conclusion. Now, if we count the neutrons, we will find that isotope B has 2 more neutrons than A. Let's examine the figure to find which isotope, A or B, has a mass number of 18. So what's a mass number? Yes, it's the atomic number, Z, plus number of neutrons. So let's find the mass number of each one. So the mass number of isotope A will be 8 plus 8 equals to 16, whereas the mass number of isotope B will be 8 plus 10, which is equals to 18. Then, isotope B has a mass number of 18. Now, which of the two isotopes in this figure is more reactive? Take a moment to think about this question. Here's a tip. You should think about which subatomic particle is related to activity, and the definition of isotopes as well. Remember that the reactivity of an isotope depends on the number of electrons only, and isotopes have the same number of electrons, meaning that they have the same reactivity. So both isotopes A and B have the same reactivity. Now, when isotope A reacts with hot sulfur, it makes sulfur dioxide, SO2. What will be formed when isotope B reacts with hot sulfur? So we just mentioned that the reactivity of isotopes of the same element is exactly the same. And this means that they will undergo exactly the same chemical reaction. So whether A or B reacts with hot sulfur, they will produce sulfur dioxide, SO2. Now, the vast majority of naturally occurring oxygen is in the form of isotope A. Which statement about the relative atomic mass of oxygen is true? Take a moment to think about this question. So the majority of oxygen is found in the form of isotope A, which has a mass number of 16. Since we have 8 neutrons and 8 protons, and this means that the relative atomic mass of oxygen will be very close to 16. Next question. The atomic number of uranium is 92. How many protons, neutrons, and electrons does an atom of uranium 235 contain? So what does this representation mean? It means that the mass number of this isotope is equal to 235, By now, this is a simple question that you should solve in a minute. Yes, you are right. All you have to do is to apply the formula of Z, the atomic number, and the formula of A, the mass number. So what's the number of protons? Number of protons equal to the atomic number, which is 92. And since it's an atom, so number of protons equal number of electrons, which is 92 as well. What about the number of neutrons? Well, number of neutrons equal to the atomic number minus the mass number. So 235 minus 92 will give us 143. Next question. How many protons, neutrons, and electrons does an atom of uranium, 238 this time, contains? So again, the atomic number is still 92, however, the mass number is 238. Try to solve this question by yourself and then let's check our answers. So this atom contains 92 protons and 92 electrons, and this time we will subtract 238 from 92, so we will get 149. Okay, so now the last question. The isotopes of uranium must be separated before they can be used in a nuclear reactor. The method of separation relies on differing rates of progress as a mixture is passed through a long tube. The heavier the atom, the longer it takes to travel down the tube. In other words, the lighter atom would be collected first. So which isotope of uranium would get through first? So it would be the lighter isotope, and this depends on the mass number. The mass number of the first isotope is 235, and the second one is 238. Which one is lighter? Yes, uranium-235 is the lighter one. So uranium-235 will get through first. Thanks for watching.